Hello everyone, I am Siddharthan. Recently, I have made an announcement video on YouTube where I said that I'll be posting a generative AI project series where we will be working on production grade, industry level generative AI applications. And the main guiding principles of these applications is that we would build this end to end. And the main aspect is also make this as production ready as possible and also work on the deployment and all the stuff that you would do in an application when you're working in a company. So this is like the main guiding principles and the criteria that we are going to use for our generative AI projects. And it's not always going to be just like writing codes on notebook, but also focus on separate front end and back end, and also make sure like the deployment is scalable and so on. So this is what we are focusing on. And the first video in this project series is going to be developing a backend kit, or it's basically like the boilerplate code that we will use for our projects, right? So the main aspect that we kind of discussed in this project is that we would have a separate front end and backend to have like a proper decoupling between the front end, the user interface, and the backend. Because let's say in this case we are using Streamlit for our front end, but we want to switch this to a more scalable proper front end tool, right? So that's the idea. So because of this, we are kind of developing this front backend separately. So backend basically contains like all your LLM operation, tool callings, agents, and whatever we are going to use. And our front end will communicate with this backend through a API. And for this API, we will be using FastAPI. So we will write this backend code as production ready as possible. So we would have used proper configuration files. We would have kind of used the environment files properly to store the secret keys, and we would have used the logging and so on. And finally, we would also deploy this on Docker with proper containerization and so on. So this is like the idea for our projects. So I thought that it would be better if first we understand this backend part and the front end part. So this again, as I said, would act as the boilerplate code. And let's say we are working on 10 projects, right? So all these 10 projects is going to share the same common backend. So the functionalities of and the business use case is going to change. Let's say we are building a chatbot, AI chatbot, or we are building a RAG chatbot, or we are building an agentic system and so on. So the core business logic is different, but it's going to have the same boilerplate skeleton, right? So all of these are going to be hosted with a fast API endpoint, and the front end can access it. So this is how we are going to work on it. So it's very critical to understand all the backend code, so that let's say later we work on multiple projects and we can easily integrate those projects with this particular code structure. So in this video, we will go through each and every part of this backend code, and then again we can start with the actual project videos, actual project, like let's say AI chatbots and so on. But it's very important for you to understand this code so that we can build scalable applications later. And maybe in the next video, right? So here we are discussing about this backend code base, backend boilerplate code. And in the next video, we can just do a similar thing with Streamlit, where we have like production grade Streamlit front end. And again, the main thing is like later we can kind of like switch the front end to a different tool, but the backend kind of remains the same. So we can do that. So this is like kind of a kickstart video where we discuss about the backend part, and in the next video we work on the front end part similar to this, and then just start with like whatever industry level applications that we want to build. So let's get started. So please considering subscribing to my channel if you like my videos. So like this video and share it to others, so that like we get like a good reach on this. Okay, so let's get started. So the first thing I have is I have my PyCharm open here. This is where we are going to work on. Again, if you are used to VS Code, then that's particularly, I mean, that's okay as well. It's not like mandatory that it should be only PyCharm or it should only be, VS Code. So that's not the criteria. So first, I'll just go ahead and create a requirements file. So I'll say requirements.txt. Okay. So here we are going to mention all the libraries that we need. So here if you see, so I have my virtual environment setup. So it's better if we could have separate virtual environments for our projects. So I've configured this. If you are not sure about this, I've already made a video on like how you can create this virtual environments in Python, how to PyCharm, so how to work on PyCharm and so on. So you can refer to that video. So once PyCharm environment and everything is set, we can just like get started with our work. So the first part is installing all the libraries that we need. So these are the libraries that we are going to use. So we have FastAPI and UVCon and this HTTPX, Pydantic, and all these things are basically to kind of set up our FastAPI endpoints. And then we have python.env. So this is to save the API keys and your Grok LLM keys and the OpenAI LLM keys to the environment variables. And then we have LangChain community, LangChain, Grok, Colama, and OpenAI. So the point of including like Grok, Colama, and OpenAI is that we should be able to configure what LLM we are going to use. So we should give that, we should have that independence of a user can use Grok LLM or they can use OLAMA, like whatever models that they want. So we make sure that we support like all these, providers as well. And later you can also include LangChain's, Google's integration for Gemini models and like other models that's present, out there. So you can do this. So first we will start with like, these three integrations. So this is the first step of installing, let's say, FastAPI, Ubicon, like all those libraries mentioned. So first create a requirements.txt file, and then we can just like install this. So I'm going to say pip install -r. So that's going to recursively install all the libraries that we have mentioned here. So the installation is happening. So we can just like minimize this for now. So we can just like let it run in the background. So I'll close this. So the next step that I'm going to do is create a .env file. So I'll give you a repository link that as like all this code, you can refer to that. You can clone that and you can like work on this, but it won't have this .env, as this is kind of like a sensitive file that would have like all the secret information, the API keys and so on. So you should never put this on the repositories, or even in your code explicitly you shouldn't mention your API keys. So we will secure this properly in a .env file. So that's like the other thing. So in this case, I'm going to have three things. So let me show that to you. So first, we have this Grok API key. So here you need to get your Grok API key from the Grok side. And let's say that you want to use OpenAI's API key as well. So let's say that, again, that's, let's say, the other model that we want to use. And then we have a separate API key. Maybe I'll call this as something like, app API key or something. So yeah, maybe like we can call that as app API key. Let's save this. Okay, so in this I'm going to like get all the key values and I'm going to paste it over here. So first is like getting the app API key. Again, this was like kind of a tutorial video, right? So for that I'm just like go to Google and search for a API key. API key is like kind of a unique key that the front end has to send and authenticate. So we won't like send the output whenever we got a request. So we first verify whether the user has sent a proper API key. The idea here is, let's say we build an application and we have given this to someone who kind of builds a front end. But let's say that someone else has access to this API and they shouldn't be able to access this. So that's why we specifically create this app API key. So the request will only get an output from our end, from the backend, only if they provide this API key. So this is kind of a security layer, just like the OpenAI and the Grok API keys that we have. So there are like more ways to create this, but again, to keep things simple, I'm just go to Google and search something like generate API key. So there are like different size that we have. So this is something that I've used for this code testing. So we have this code pen thing. So it says API key generator, and then you can just like kind of like click on this generate API key. So this is going to give you some unique alphanumeric combination. So I'll close this and put my app API key over here. So whenever the front end is making a request, right, it should give this app API key. So that's the idea for this. So similarly, I'm going to add my Grok API key and my OpenAI API key. So this is again important because we're going to support Grok and Open API key. Let's say if you don't have a OpenAI API key, and because like again we have to pay some kind of like money to access the APIs and so on, right? So if you don't want to do that, just like leave it as such, or say something like NA. We won't use this, right? When in our application we won't use this if we put this, but I'm going to use OpenAI as well, so the user can select OpenAI models as well. So I'm going to use my key, but what I'm saying is like you can leave it as such. You can just like get the Grok API key alone, because Grok as a free tier, so you can just like use this. Also along with this we are going to use Olama as well, so that's fine. So the idea here is like fill your Grok API key and OpenAI API key, and it's fine if you don't have a OpenAI API key because it requires like the payment details and so on. So you can just like type something like not available or something. So I'll just like move this to a different window, and I'll just like save this keys as, again, this is a secretive thing and we shouldn't, as I said, kind of like show this deliberately on the code. So I'll just like fill this in a moment. Okay. So I've got my Grok API keys. I have pasted it. So now I have to get my OpenAI key. Let me do that as well quickly. Okay. So I have three keys here. One is okay. So I have my Grok API key. So I've also filled in my OpenAI API key, and finally we have app API key, like the key that the user, the front end has to send. Okay, so let me close this and I'll move this PyCharm back. Okay, so what I've did is like I've filled in like all the three key values, the secret key values, and I'll give this particular file in the repository. So I'll create a new file. This is just a reference to the ZNP file. So this tells you like what are all the key and value pairs that we need to mention in a .env file. Again, this is just a template or like reference that you can use. So I'll call this as env template to just tell you that what are all the fields that we are currently passing to the you know to the environment variable. So we have grok API key. So I'll say something like your grok API key, and then we have this OpenAI API key. You have to put your OpenAI API key. You don't have to put everything in quotes. You can just like put the variable name here and the actual key value here, but make sure that you don't have any space like in the key and the value pairs. And finally, let's say we have this app API key. Okay, so open this. So this should be called as app API key. Again, so this is the key that you have generated, right? So generated API key. This is like something you can generate. So this is the one that we have just generated just now. So these are the things. So what you have to do is once you have cloned the repository, you wouldn't find this .env file. So what you can do is once you have cloned it, create a file and call this as .env, and within that create these things: Grok API key, OpenAI API key, and app API key. So get all your keys and fill it over here. And it's okay to leave this OpenAI API key as it is if you don't want to use OpenAI, but make sure that you include it. That's necessary. But again, you don't have to get your OpenAI API key if you don't need this, but just make sure that you add this over here. So this is the next step. So the first thing that we did is, so we have ran the requirements.txt, so we can see like all the libraries has been installed. Let me clear this quickly. And then we have created the .env and I've added like all our secret keys and so on. Okay, so that's the next step. So now I'm going to create another file and I'm going to call this config.json. So this is going to contain all the configuration that we are going to provide. So this is again going to be a larger file and later we will kind of change this. But for now, we can just like mention whatever configuration we need so far. Configuration is basically like sometimes we want to change a few stuff. It can be like, what's the port API should run, whether it should run on 5000 or 8000, or what's the host it should run, whether it should run on local host or we are trying to run it on somewhere else and so on. Or we can also say that these are all the LLMs that I'm supporting. So all these configurable things that basically the things that you can change in your code often, so we put that separately in a configuration file, so that we don't have to change anything in our code. So instead we have a separate file where we can change this like whenever required. So that's the idea. Say for example, I'm creating this as JSON. It's kind of like a dictionary structure. So I'll create this, open and close this parenthesis, sorry, the curly braces, and the first parameter is going to be LLM. So this is a key that I'm creating. So this key is again going to contain another dictionary as its value, and here I'm going to say Grok, and okay. So next thing is, let's say we support Olama, and finally let's say we support OpenAI. So this is just to give a list of providers that we support, and in each of this list we would like kind of mention like what are all the models that we are going to support. Right. So I'll open my browser. So I already have created the Grok account, Grok API keys, and so on. So if you haven't created this, you can just like go to Google and search for Grok, and you will see this API key section, or just search Grok API key. And also they have this list of models that you can use from. So I'll search for this Grok model. So you will see this production models. So from this, we can just like choose the models that we want. Again, you can like include as much models as you want that's present here. But let's say I want to mention this gamma to 9 billion iteration. Like, so let's say that we have this model, and then 70 billion model, 8 billion inch. So let's say that I want to use these three models. So the idea is the user can have a chat bot and they can choose like from any of these models. So I'll copy this Gemma to 9 billion iteration first and I'll put it over here. So put it in quotes within this list. So this list is going to contain the list of LLMs that each of this provider is going to support. So now I have Gemma 2 billion iteration, and then I have this Llama 3.3 70 billion iteration. So I'll put this over here. And let's say we have 8 billion iterations. So these are the three models that we are supporting. So when a user chooses Grok, so we would probably have a drop down in our front end, and once they click on Grok, we would say that from Grok you can choose any of these three models. Again, you can include more models as well, but let's say for now we are supporting these three things. And Olama, so the other thing that you have to do is like probably install Olama so that we can run our models locally as well, because in some applications we would prefer having all our data and models in our local machines instead of like sending it to cloud platforms like Grok or OpenAI, so that the data is secure. So let's say that we have an option to provide like Olama so that we can use like local models. So just like go to Olama if you want to download it, and to search the models, right? So go to this model section and they would have the list of models. So let's say that you want to download Gemma 3, right? So what you have to do is go here, choose like the model size that you want. So if you want the 1 billion iteration, click this 1 billion iteration and it would tell you the command to run this, such as Olama run Gemma 3 1 billion, right? So what you have to do is open your PowerShell. Once you have installed your Olama, you have to say Olama pull and this model name. So I'm going to say Olama pull. Let's say I'm mentioning this 1 billion instant models, which is like a pretty smaller model, just like 815 megabytes of size. I'm going to say Olama pull Gemma 3 1 billion model. So this is pulling the model, so you can see like the model is getting downloaded. So once this is downloaded, we can like list all the models that we have. So currently I have these models. So to look at like the list of models that you have, you can run this command called as Olama list, and that's going to say like what are model like that you already have. So currently I'm importing this model, but apart from this model, I will like call these three things. Let's say that I want to mention these. First, let's say I'm going to mention Gemma's 2 billion model. So that I would put in this Olama. Similar thing. So in this list, put this over here. And the next model is we have this DeepSeek R1 smaller model, the 1.5 billion model, but this is a reasoning model. Let's say if you want to give a reasoning model to the user, you can maybe mention this. And finally, let's say that 5 is from Microsoft. So let's say that these three models are something that we would use. But again, if you want to use this Gemma 3 billion, Gemma 3 1 billion, you can also use that as well. So let's say that we have these three models here. Maybe you can include this. If I run this Olama list again, right? So now you would see this Gamma 3 1 billion. Maybe we could include this as well. So in Grok, we support three models, and for Olama, we again support like four of these models, and finally OpenAI. So OpenAI, you can just like go to their site and like kind of look at like what are all the models that they are supporting, and then use it. I go to OpenAI models list API. Let's see if we have something there. Right, so these are the different models that we have. So if you see, these are like cost optimized models. I'm just like going to kind of use these things. So we have O4 mini, we have like nano and so on. So how to let's see how we can get this model exact model names. So this is the exact name that you have to use for Olama. This is the exact name that you have to use for Grok and so on, right? For OpenAI, just search for this production, this like site called as models, OpenAI models list API. Go to this site, and let's say we are focused on let's say this nano model, GPT 4.1 nano models. So click this and you will like see like all the cost, like what's the price and so on. So this is like a cost efficient model, so it should kind of charge you a bit less. So this is the exact name that we have to use. So you have this GPT 4.1 nano, we have this particular date, right? We have to put it in this, let's say OpenAI. So similarly, I've shortlisted four other models that we can use. So let me add those as well. Again, if you want to use a different model, just like go here and select something. Let's say you want to use the GPT 4.1 mini model. So you can just like again go to this one and just copy this name, right? And the other two models that I have are like the two reasoning models. So we have O4 mini. I think that came like pretty recently. And then we have O3 mini. Let's say we have these three models. So Grok, we are providing four models. Olama, we have, sorry, Grok, we are supporting three models, 9 billion iteration, and we have like 70 billion model and a 8 billion model, 3.1 and 3.3. And in Olama, we have different models. So we have from Google, we have two Gamma models. We have like DeepSeek reasoning model from DeepSeek, and then Phi from Microsoft. We have like all these things. Phi is also like a smaller model. It has like different sizes. I'm using like a smaller model as my GPU is like only like 4 GB, and then we have like these OpenAI models supported as well. The idea here is, right, again, another reason for using this configuration. So after a month, there is a chance that OpenAI would make some changes to this model, so they would update this. So now your kind of this date may change, or the model itself may change, and they may change this GPT 4.1 mini. So they may remove this and add, let's say, GPT 4.2 mini. Now if you embed all these things in your code, you have to drill down detailing in your code and you have to change this. Rather, what we are doing is, instead of putting all these things that can change in the future, right, instead of putting all those things in the code later which becomes tedious to change this, we are having in this configuration. So what you can do is, if some update is happening, you can just simply change this in the configuration file. You don't have to do anything in the code, because we are going to take everything from this configuration file. So that's going to handle everything. So that's like the other advantage of this. Okay, and let me just like make it better. I think this is okay, but if you want this to look slightly better, you can just like put all these things in a different line. Okay, so this is the list of Grok models, and I'm just like creating different line spaces. Okay, so we have this. So we have like the list of LLM models, and this is just for LLM. Its configuration file is not just used for LLMs and to tell like which provider and which LLM to use, but there are so many configurable objects that we would have, or that we would use in our code. Say for example, I'll create another key value pair. So this key value pair is LLM, which contains a dictionary of like all these details. Later we would use this in our code, and now let's say that I call, I'll create another key. So this is the first key, which is LLM, and within this LLM we have this grok, polam, and everything. So I'll say like we are creating another key value pair again, which is also a dictionary, and within this I'm going to say host is going to be, let's say, localhost. Okay, and port is going to, let's say, it's going to run on port 8000. Let's say this is what we are mentioning. So these are some configurations. So let's say some other service is running on 8000. Now you want to change this to port 5000. You don't have to change it in your code. So rather, we would pick this port from this port. So if you want to change something, you can directly change something over here. So this is the idea. So instead of like putting this configurable things in your code, which becomes tedious if you want to change this later, you have to drill down and find like where exactly you have put your code. This is because when you look at this code like 2 months later, 3 months later, we sometimes like kind of feel lost, and it's become harder to manage the code and kind of have to, when we have to change something. But if you know that few of these things are going to change, let's say the versions of this models and the providers and so on, you can simply add it over here. And let's say if you want to add another provider, let's say you want to add another provider like Google, you can just create another key value pair like this. You can just put like Google and then like, Google or Gemini, and you can like list all the models that they pro. So you can easily make this configurable. Usually we can also put our API keys as well in this configuration.json, but the idea here is like I wanted to add like two files. One is this configuration file, which doesn't contain any secret information, but it contains configurable information. But env, the environment variable file, should contain only the secret information. So just to separate this, right, I'm kind of having this, because if I put the environment secret keys in this configuration.json, then I won't be able to upload this to repository, right, because that contains like the sensitive information. So that's why I'm kind of maintaining these two files separately. One is .env for the all the secret keys and the values that we have, and then configuration file, we can have like all this configurable non-sensitive items basically, so we can put it over here. So here we have LLM and API. So similarly we can just like scale this up whenever required to like use other stuff. So let's say that we want to use a MCP server, so we could include all the MCP servers available, like mention the ports and so on. So all these can come under this configuration.json, so instead of putting like hard coding this in our code. So that's the idea. So these are the things so far we have completed. So we have installed the required libraries. So and then we have kind of like in this, we have these three things right in our env template. So we got our Grok API key, so we have filled it in the .env, and then we got our OpenAI API key, filled it, as well as the app API key. So basically, the API key that the front end has to provide to access the resources in the sense like the endpoint and the resources that we are going to provide. And finally, we have kind of created our configuration.json file. So this is what we have completed so far. Okay, so now we can get started with the actual code and everything for this project. So I've already created this, and probably it won't be ideal if I kind of sit down and write every line of code and explain this to you, because like this contains quite a good amount of code and there are like so many things that we have to understand. So what I'll do is I'll just like close this and I'll up this all this files ready. I can paste it over here and I'll explain you like file by file what we have and so on. So I'll copy this file called as main.py file. So this is what we call as a entry point file. So this is the file that's going to start our API and everything. And then I have another folder that has like all the main piece of code called as app. I'll paste it over here. And apart from this, let me quickly check if we need some other things. Okay, so we have requirements.txt, we have main.py file, we have env template, config.json, env, and app. Okay, so these are the things that we have. So now let's try to understand what are all the aspects that this API contains. So we have this main.py file. So if you see, like we are importing like several of these things. I know that this code looks very complex and all that, but I'll explain this to you in a very simple way so you can like understand this. And the other aspect is that you don't have to understand each and every line of this code right away. Take your time. Make sure that this code is running on your machine. So I'll tell you like all the entire like steps to run this. Like, make sure this is running. Apart from this, everything is fine. So you can just like slowly in a day you can just like go through this code, let's say 1 hour a day, like 1.5 hours a day. In the meantime, I'll also be like making another project videos and everything. So in this continuous process, we would integrate all our projects. Let's say we build a chatbot, that's let's say our first project, so we would integrate this with this particular backend, and at that point you would get a better understanding of this, and later again we would work on the second project, and at that time also you can understand this a bit later. So just like do this as a continuous process rather than sitting down at once and going through this code completely. If you can do that, that's great. If you can go through this at once and understand all these aspects, that's okay. But if it feels tough, just do this like little by little, that's okay as well. Okay, so let's try to understand what this code does first. So I have all this code written. So let's maybe uh, first say that we don't know what it does, but let's understand what are the functionality it has, like what is the purpose of this and what does it serve. So we have like so many codes here. So I have opened my main.py file, as I said, which is an entry point script, which is like the starting point of our application. And now here I'm going to say just run this main.py file. So make sure that you have uh, like installed all these libraries. Make sure that you have created the .env file, put your all your like KPI keys, then only it would work. So you have to have your env file, config.json, and this requirements.txt libraries should be installed. These things, one is install the libraries, create your .env and put your API keys, and the other thing is have your config.json. Okay, again I'll give you a repository that you can clone, so all these files you would already see there. So now I'll run this. So when I run this, I'm going to get this thing. So we have like all this logging that you can see. So this is another part we have included. So we have added logs in each and every step so that we know like what are all the steps completed. If you see this, it says loaded app configuration from this config.json. So it read the data presented configuration and it has loaded it, and it has loaded all the environment variables, course middleware have been configured, and like we have like so many things. And it says that starting fast API server at this particular host, which is localhost colon 8000, which is what we have mentioned in this configuration.json file. So we say that localhost 8000, it should run. So it is running here. So now click this link. You can just do a control click as well. So this should work. So it says like pretty print detail not found. So this is what you have to say if it's running. If something is not running, you probably would get a error like this. So let's say if you click this link and it says something like this, the site can't be reached, then there is some issue. If everything works fine, then in this localhost colon 8000, you would see this pretty brand detail not found thing. And I can just put a forward slash and type in docs. So this is going to open the Swagger docs. So this is all the information. So this is the LLM API that we have created. So this is the name that's present in this main.py file, we have this title as LLM API, right? So that's what it kind of basically mentions. So here we have three endpoints. So this is what we call as endpoints. So we are creating one single endpoint, which is this LLM API. Sorry, we are creating like one API called as LLM API, and within that we are creating three endpoints. So the endpoint is basically like each of the endpoint would serve different purposes. So here we have like two get APIs, and then we have like one post API where we have to send some data and get some response back. So what this get API does is it just like do a health check. So from the front end, like or from different places, we want to check whether the server is running. So let's say that this is our server and it's like UVCon server, and let's say it's running on this port. If someone want to make sure that everything is running, they don't have access to the backend, right? So usually the front end developers will be working separately and you would be working separately, and once you have deployed everything, you would tell them that everything is ready. So let's say that they want to quickly check if everything is working, then we provide this API where they can just like try it out, right? So when they try it out in the sense like they would just call this URL. So in Swagger, if you just go to this doc, so this is what we call as the Swagger documentation for the fast APIs. So click on this drop down and you will see an option called as try it out. So when you try it out, here it doesn't require any parameters. All you have to do is just like execute, and then it would say status okay. This means that everything is working fine. So we have written this health endpoints and show all these things like how this health endpoint is showing up here, what is this LLM option, get answer, and so on. So I'll explain all these things to you, but for now understand that we have an API that basically first test that if the server is running. If it's not running, then it would say that something is going wrong or something is not working, so that we know that we have to kind of work on that. So the first is a health checkup endpoint. For usually in the health check, right, even when we deploy it, like we would have this load balancer and different software components that manages your deployment and stuff, that handles the request and give it to the server. So those components also require this health check endpoint to make sure that everything is working. So those software components has to make sure that like the API is up and running. So we also provide this endpoint so that those components can also make sure that everything is fine from the backend. So this is for health check, and for that particular reason we won't use that API key. API key in the sense, so we have created this in this env template, we have this app API key, right? Like all the other endpoints that we have over here requires that API key that we have just now created, and other things like doesn't require that, like so this health doesn't need it, but if you want to use the other endpoints, we have to pass this API key. So let's see how we can do that. Let me quickly copy this API key. I hope you remember. So we have just like gone to Google, search like generate me a API key, and we have generated a API key. So this maybe I can change this later. I'll put it in the env template as well. Okay, so this is my env template and this is my app API key. This is the same API key that's present in my .env file. Okay, so similarly, create your own API key. Copy this, and now I'll open my LLM options. What this does is provide the LLM option that's the user has asked. So when you click on this try it out, the one thing that it requires is your API key. So this API key has to be sent from your header. So paste your API key over here, and when you click on execute, it says like all the list of models that you have. It's basically what we add in our configuration file. So you see this configuration.json, right? So here we said that we are going to support three LLMs. One is Grok, Olama, OpenAI. So we are basically extracting all this information and providing that in the form of a API endpoint. This is basically, let's say we are building the front end in Streamlit. It's a chat bot, but the user can select whether they want to answer a particular question using a Gemma model from Grok, or if they want to use a GPT 4.1 from OpenAI, or they want to use DeepSeek from Olama, right? So we give all these options. So we would have a drop down where the user can select the provider, and for that provider we would have another drop down where they can select like specific model that they want to use. So now this endpoint, we provide this to the front end person who is developing this front end, and they would integrate this API there. So basically that drop down that we have in our Streamlit gets the data from this endpoint. So that is for this purpose. So again, I'll try to see if I can show this to you. Let's say I'm searching chat GPT. Stay logged out. Okay, so here you have this option to choose a model, right? Let's say that you are signed into ChatGPT. If you choose this drop down, it has like all this list of models, right? So we are going to do a similar thing, but we are going to have two drop downs. One is to select the provider, whether it's Grok, Olama, or OpenAI. And once they click this, we are also going to provide another drop down where they can select like the different models. Actually, in chat gpt would see like the gpt o1 models, o4 models, and so on, right? So we are just going to implement a similar thing, and the data for which we need to kind of select from this is going to get its list of providers and the llms from this particular api. Okay, the next aspect here is we have created another endpoint, which is a post endpoint. Post endpoint is basically like you post some data to this and we get an output from this. So get you usually like don't send any input to the API. So I'll click on this, try it out. Again, I have to provide the API key that we have created. So this won't work if I send some API key. Let's say that I'm just typing in some random API key. So this is not the actual API key. Let's say that if we send this, it's going to say invalid API key. See, so when this is called from the front end, they have to provide the actual API key, which is this one, right? And this is, as I said, if you remember, we have configured this in our .env file. This API key can change. If you change this .env files app API key, then we have to provide that API key. Okay. So here, what I'm going to say is like mention this requires three things. One is like the provider. Now, let's say the user has selected a model. Let me maybe show this somewhere. I think if I open ChatGPT, right, so that would probably make more sense. Okay, so see, we have this, right. So we have this ChatGPT, and we can select GPT 4 with scheduled task 4.503 and so on. Similarly, we would have some feature in our front end to choose this also with the provider. Let's say the user has selected OpenAI and they have selected this 4.40 model, right? So let's say that they have selected that and they are trying to ask a question, something like what is YAML? Let's say that this is what they are asking. So they have selected a model and they are asking a question. But for our application, they are going to select a provider, a model, and then they are going to ask a question. So these are the three inputs that they will kind of send us, and then we have to give an output like this. Okay, so this is what we are kind of trying to build. Let me move this to some other place. Okay, so let's see. These are the three things. One is the provider, which the user would select from the dropdown, the first dropdown, and then there would be a second dropdown where the user is going to select a model, and finally they can type in your question. To test this in the form of API, you can just like open this LLM get answer endpoint. So this basically gets the answer from the LLM. Select this, add your API key over here, click on this, try it out. So we have already pasted our API key in the header section, and then we have request body where we have to send it. So let's say that we want to use Grok. So I've already pasted my Grok API key in the env file. So this is going to work. So I'll say Grok, and let's say that these are the list of models available from which the user can select, because these are the ones that we are providing. If you want to add support to a different model, just add this to the configuration file. If it's Grok, just add it in the next line, put a comma, add it in the next line. If it's Olama, you have to put it that. Just like do that, right? So now let's say that I want to use the Grok's Llama 3.1 8 billion instant, right? So all this data, this payload basically comes from the user selected drop down value. And let's say the question is what is AI? Let's say this is what they are asking, and click on this execute. So this is now going to give your answer in a dictionary in a JSON object format where the key is answer and the answer contains like the actual answer for this. So if you want to test this on curl, so you can use this curl in Linux terminals and so on to test the API. It basically does the same thing. It kind of adds this header API key. So this one has the API key as header. It pastes the API key that we have given it, and it kind of sends the payload in this section. Okay, so this is how you have to do this, and this endpoint can be called from this http localhost 8000 LLM get answer and so on. So currently this is only running in our localhost. Localhost means like you can only access this API from your own machine. If you want to make it available, so we would probably put this in a EC2 instance or some virtual machines on cloud, and then we could kind of give this access to someone else building it anywhere, right? So any people using this can kind of access this. So this is the entire idea. So we have three things over here. One is the get kind of health check endpoint, which is going to tell you if a server is up and running by sending the status as okay. If you don't get the status okay, that means like the server is not running. You have to restart it, like make some changes there. And we have another endpoint called as LLM options, and then we send the API key in the header and just send a payload. Sorry, this doesn't get a payload because it's a get endpoint. So it's going to send you the list of providers and the models and stuff. And finally, we have the LLM get answer. Again, this requires a API key so that we can app this secure, and then we can send the payload with provider details, models, and questions, and so on. So this is how we can test this. This is one way of testing this, and there is also another, like the standard way of you test the APIs. So that's there is a tool called as Postman. Again, this is not mandatory, but if you want to build like all these APIs and so on, like Postman is a good way to test it. It's we are going to do the same thing of like what we have done here, right? But I'll show this up. This can be done in Postman. We maximize this. So these are the ones that I've already tested. Maybe I'll close this and I'll show this to you from the start. Okay, so we have this getting started thing. So I'll just like leave it as it is. So I can once this is installed, I'm going to click on this plus symbol. So that's going to create this page where I can give my URL and I can test it out. So this application is running in our localhost 8000, right? So this is where it's running, localhost 8000. So we have to copy this link, or the other way to do this is we are going to test specific endpoints. So I'll open this. Once you test this in Swagger, you will also get this request URL. So this is basically the localhost and the port and the actual endpoint from which you have to test this. So copy this URL. This is the exact URL that a person from the front end would also be using. Let's say we provide this URL. So this doesn't require any headers. This is where you would put your API key, but this one doesn't require any headers and so on. And here you can choose whether it's a get endpoint, get API method, post method, put method, or anything. So for us, it's a get method. So I've chosen this as get method, localhost 8000 health. Click on the send, and you would see the output over here. Status okay. Okay. This is how you can test. It's the same thing of what we have done in this Swagger, but it's like Postman is specific for testing this API tools, and it's kind of like good in that particular way. And then click on this another tab. Now I have to test another endpoint, which is, let's say, LLM options, right? So we have two tags. One is health tag and the other one is like the LLM tag. And we know that this is the request URL, which is same localhost 8000 slash LLM option. So what I've done is these two are similar endpoints, right? So basically those two kind of handles the LLM related services. So I've created a path called as LLM slash LLM options, and for answer we would have LLM slash get answer. So you can just like group the similar endpoints together. So that's why we have something like this. So I'm going to go to this request URL, copy this URL that we are seeing here, put it on your Postman. So we have localhost 8000 LLM slash LLM options. This is also a get endpoint, right? So this is also a get thing, but we need a header. So we need to send this header. Click on this, try it out, copy this header, and see this one is important. So this API key that you're seeing here, this is the name of the key that we have to send, or you can also see this in this curl request. So the name of this is API key. So copy this API key, come back to your Postman, open your header section. In the key, put that variable name, the key name, which is API key, and in the value give your actual API key value that we have configured in a .env file. So put it over here. So what this is going to do is call this endpoint 8000 slash LLM options. It's going to use this API key so that the backend can verify the request. So it's like it says that this is a kind of verified request. So you can give the output. We don't have any body, as again this is a get method. So now send this. You're going to get the same output as Grok, Olama, OpenAI, and so on. So now finally we can test our post endpoint, which is LLM slash get answer. Open this. You will, like, once you have tested this on Swagger, right? So you will see this curl and request URL and so on. So I'll copy this request URL, paste it over here. But the important thing is I have to change this get to post. So now in the API key, I'm going to copy the same thing, API hyphen key. And then in the value, I'm going to put it this particular number, alphanumeric combination. And we can put it over here. And the other main thing is we have to add the body. So in this body, so we have added this in the, okay, wait, this is not saved. Oh, I've added this here. Okay, no problems. Let me just paste it over here. We don't need this here. And once I've given this API key, I'll come back to this body. This body I have to choose a raw, and then I can choose my payload, like what are all the provider that we want to use, what is the model that we want to use, and ask a question. Let's say that we have like Grok and this is the model and this is the question. Let's say like let's ask what is ML, and we are using, let's say, same Grok Llama 3.8 billion instant, and let's get the response. So first the backend authenticates the API key that we get from the headers, this API key, and then it looks at this payload as per the required model. It's going to like give you the output. So let's say that now we want to use a different model. Let's say in our configuration we have Ollama and OpenAI, right? So what if we need OpenAI and GPT 4.1 Nano? Let's say that we want to use this model. So in the first step in the LLM options, we got an output, right? So from this I'm going to copy this OpenAI, which is the provider details that I have to choose. So I'm going to change this provider to OpenAI, and the model name I'm going to choose is to GPT 4.1 Nano in this particular date. Let's do that. And let's click on send, and you would get this response. But now this response is coming from OpenAI. So ML typically stands for machine learning and so on. So all these things. And we can also test this with the Ollama models as well, the local models that we have hosted. Let's say and copy this Ollama and paste it here. And model, let's say we use Gemma 2 billion, and the question can be the same question, and send it. So here we are just like changing the provider, changing the model, and testing these endpoints. So now we would get the API. You can see it's a bit slow because we are running this in our local GPU. Even it's a small model, this is like taking quite some time. But yeah, we would see the response, right? So we have the definition of machine learning, we have like all these steps. So these are the three main endpoints that we are creating. The reason is it's not like we are going to use the same endpoint, but the idea is this: you create a front end with some functionalities, like whether a user can ask a question, they can choose a model. This is basically like a user has access to a multi LLM chatbot where they can ask a question but also select like a specific LLM that they want to use, and then we kind of have this thing to give them a response. Let's say that they want to ask a question by sending an image. For that we have to use a multimodal LLM that can support both images as well as text. So they can choose that LLM, and then they can ask a question. So we can like handle all those things. So this is just to give that flexibility to the user by not just like locking them with this is the LLM, this is what you have to use. Instead of saying that, we're going to give them options on the provider that they want to use and the model that they want. Just this is just a simple use case. So similarly, we would build our project, but expose all these functionalities in an endpoint so that the front end can securely use this. And tomorrow, let's say we want to switch from Streamlit to a different front end tool, let's say Angular or Node.js or something, right? A front end person would do that. We probably won't work on the front end as like it's not in our scope. If you just want to build a prototype kind of front end, we can use Streamlit and show it to, let's say, your managers or like in your demos and so on. But when it becomes a project, some other front end person is going to do that. But just to give that feel of how the application is going to look like, we can build a prototype in Streamlit. But once you, let's say, move your front end to a different front end tool, the backend doesn't change because we are just like providing this as APIs. Now your Streamlit app can access the APIs from Python codes, and even different front end tools can access all this with API. So this is like the standard way of communication between the front end and back end, and this is the architecture that we are going to work with. So we have a FastAPI backend. So all these services are connected with our FastAPI endpoints, APIs, and the front end can be anything, right? So we have these two components of front end and back end, and these two are going to communicate with the APIs. So with this functionalities, I hope that you understood like what are all the functionalities. We have like three main endpoints. Again, this is just for a demonstration purpose. We would kind of build on top of this. We may need a RAG endpoint where, or for RAG, right, what we need the documents, we need like the user's question. So we have two endpoints there where in one endpoint the user sends a document, so we store this, process this into a vector DB, and another endpoint where maybe they can ask a question, and so we look at this document, perform RAG, and we send a output. So in that case we have a document upload endpoint and we have a get answer endpoint, right? So similarly for each project we would kind of build all these different endpoints, but the base code, the boilerplate code remains the same. So we have this app LLM configured and so on. In all those cases we can keep this LLMs as configurable, right? So this is the entire purpose of this boilerplate, or this what I call this as a generative AI backend kit, where we are going to build all our projects on this particular backend or this boilerplate code, only the functional aspect change, business logic change, like whether it's a chatbot or whether it's a RAG or a agentic system. All of these things we are going to deliver it in the form of API, and it becomes easier to deploy as well. So later we would wrap all these things in a container and we would deploy that on a EC2 instance or some virtual machines on cloud. So that's the entire approach that we'll be taking. So now let's maybe quickly go through the code that we have. I'm not sure if we would be able to complete all these things in this particular video, but anyway, let's try this. So we have this main.py file. Maybe here I can create another file called as init.py. I'll tell you what is the purpose of these things. Okay, so I have this main.py file, which I said is the entry point script, right? And the main purpose of this script is to uh, start the API in the given host and in the given port. So we have like different functionalities to handle this. Okay, so first we are importing FastAPI, which kind of used to build this FastAPI. CORS middleware. CORS is what we call as cross-origin resource sharing. So when you are building something, when your backend is on a different domain, let's say xyz.com, and your backend is on xyz.com and your front end is on like abc.com. Now your browser doesn't allow this to share the resources, like it doesn't allow the two domains to communicate or with each other. So we would say that uh, allow cross origin resource sharing. That means like it's okay if the front end is from a different domain, allow this. So we kind of tell this flag to the browser, so the browser allows this. So when we allow origins as asterisk, that means like I don't care what the domain is, you can allow whatever we want. But the actual idea here is we would kind of specify like specific domains. Let's say that our backend is running on xyz.com. xyz.com is, let's say, from a company name, right? So it's something like that. Let's say that OpenAI is developing this. So this would be running on this domain of openai.com, some llmapi.openai.com, and frontend can be like several companies would access this. If they want any companies to access this is kind of a cross origin that they would allow. If let's say we only allow 5 companies, 5 domains, abc.com, 123.com, something like that. So we mentioned those specific domains here. So that means only those domains can access this backend resources. So that's what that. We have course origin and this API routes. We have this folder called as app, and within this app called as like this is the structure that we have. I'll explain that in a minute. So we have the routes, configuration, and so on. This API routes is what kind of like we add this. This endpoint is what we call as route. So we have a health endpoint route, we have LLM options route, and get answer route, and so on. So all these are defined in this routes folder. And then app.config is basically to load your config.py file as well as your environment variable and so on. And then we have logger to log all the details. Like if you see this, right, it says this is the last request that we made. So we made the request from Postman, right? It says API key verification successful, LLM answer request received. So it says Olama Gema 2 billion, and the question was ML. So we log all these aspects to, this is easier to debug, and this is like a more standard way of development where we kind of like have all these logs together and we kind of like work on it. So that's the purpose of this. That's coming from this logger, and then UVCon is kind of the server that we have, and then we are naming this FastAPI server as LLM API, CORS middleware, and so on. So we have all these things, and we finally start this in this particular host, and this is the port it's running, and so on. So we have all this main.py file, and the main purpose is just to start this FastAPI, right? So as we have discussed. Now let's discuss the folder structure. This is my project directory, which is this 2025. This particular date is a project directory that I'm working on, and I have a requirements.txt file in this project directory, which has all the list of more like libraries that I need. And then I have this main.py file, which is my entry point script that would start my API. I have a config.json. env template is just for a reference. It's not important for our code specifically. We have a config.json file that has like all the configuration information, and then we have a .env file which has like all the secret keys, API keys, and so on. And then we have a logs folder which gets created automatically in the runtime. So it's not like we manually have to create it, so it gets automatically created. If you remember, we didn't create it. So when it runs, like all the logs get saved in this app.log file, so that we can easily like look at all the logs that we received and so on. Instead of looking at in the terminal, in the console, we can look at it in the file as well. So we have like all the time details, info, warnings, and so on. If there are any errors, those errors would be kind of like saved here. This again, as I said, would be automatically created, and then we have a folder called as app, which basically has like all this important folders and the codes that we need. So we can try to understand this. So First is, let's discuss about these two things. Like in app, we have API that's going to handle all the routes details, like how we route a specific request, right? So how it's going to go to the health route, or how we are creating this LLM option, get answers. So all these are handled by this API folder, which again contains this routes and so on, right? So the API key verification part and the routing part is present in this API, and then we have a LLM folder that's going to handle everything that's related to LLM, like which LLM to use and so on. It's the idea of when the user is sending this request, right? The provider details, model, and so on. We have to choose this model. So all this are basically coming from this code that's present in LLM. So if you, as you can see, we are making everything modular so that we can handle everything separately and we can easily identify where everything is going wrong. You can also put all of these things in a single file, but when something breaks, it becomes really hard to debug it and fix the issue. So that's why we are making this as modular as possible. And services is basically the a code that contains the actual business logic, like how to get the list of models from the configuration, and we also have another file called as QA service. It contains like how to basically send a question to the LM, get a response. The actual functional part of our application gets saved in the services folder. Okay, so this is like the contents of this particular thing. Creating a docs file here as well. Maybe we can later remove this, but yeah, for now this is okay. So we have to probably change some code, so we don't need this logs here, so we just like need logs outside this aspect. Okay, so let's quickly try to understand all these aspects. And in each of this folder, if you can see, I've added a init.py file, underscore init initiation file in underscore.py file. So it's basically an empty file in most places. And once I add this, you will see this small circle in the folder, in the directories folder, right? So what it does is, when you add a init.py file in a folder, then Python treats it as a module, as kind of a library, right? So if you see this, we are importing this app.api, app.config, and so on, right? It's just like importing your Python libraries, and that's doable by including this init.py file there. So in all these folders, we are adding this init.py so that we can easily import all these things like later in our code, right? So here, if you see this, right, so we have these two files, config.py file and logger.py file in our app directory. If I open this config.py file, this has the code to load your environment variables. So you have this .env and load.env, right? So this is going to read the key value pairs, read the values that's present in your .env file, and save it in the environment variables. Say for example, we have this grok apk, right, and the actual value in our .env file. So when this config.py file runs, when we import this, this is going to save all the API keys to your environment variables. So when we call the grok API model, it's going to look for the API key in that environment variable. So that's the process. So the purpose of this config.py file is to load the environment variable values to the environment variables, and again load the configuration file. So if you just like see in this code, we have all these exceptions getting handled and so on, but the main aspect is this two things. One is your app config and the another one is your env config. So these are the two things. And if I come back to this main.py file, I can maybe import this env config as well. I'm not going to use this, but I can import this. What's the purpose is, when I import this app.config, it's going to load the app config and the env config. So env config get loaded into environment variable, but it also gets served as an object. If you want to, let's say, pass a API key to a particular function, right? So let's say that you call this chat grok and you have to pass this grok API key, the actual value, instead of getting it from the environment variable. This gets stored in this variable called env config that we have created in this thing. So we have env config app config, right? So this gets saved in this is basically a kind of a dictionary. Later we can access it from here. Okay, so these are the purpose. So you have this config.py file, and the sole purpose is to load your configuration and your environment variable. So these two lines looks at the environment variable values, the env file, and save this in the environment variables. This is like, you can just like go through this code. Here we are just like reading this configuration.json. This is like mentioning what is the path. So it's like config.py is file in this directory. So when I say path of file, this is the exact path of this file. We are going to this parent directory. So parent directory of this config.py file is app is the parent directory. Parent directory is basically the directory where config.json is present. So we are saying that find the parent directory of config.py, which is app and then go to the parent directory of this app, which is this project directory. So there you will find this config.json. This is what we are saying here. So you're saying that path of this config.json is parent of parent directory, and then you would find this file called as config.json, and it loads with this thing. So it's just like opening this configuration.json file with this with open configuration file as if, and json.load basically reads this JSON file and loads it into a dictionary. Later we can use this, pass it to the endpoint that we have seen, like LLM options and so on. We can work on it. We don't have to do this every time. If you want to access something in this configuration.json, now you don't have to do this every time you need this. All you have to do is, like, you don't need to write all this code separately. I can just import it. So from app.config, import app config. That is all I'm going to do. Now I have the app.config content, right? If I want to load this environment variable, I don't have to run this entire script. All I have to do is just import env config from this. This is a modularity that we have and the reusability that we have in our code. So similarly, if you open your logger.py file, here we are creating a file called as app.log. So we are creating a directory called as logs, and just mentioning that in this logs directory, create a file called as app.log, which is getting created here. And we are saying that, if that exists, like, if that exists, that's okay. If it doesn't exist, create this folder called as logs, and then just like write all this logs to this file called as app.log. And then we are tagging this to the name called as LLM API. So that means all the code that's been running, like all the scripts, like all the functions and the py scripts, are going to use this LLM API, right? So all these are like the configuration of how this logs has to be, how it should like give this and so on. So it kind of like sends the output in the terminal, in the console as well. Like all these things happen. So just understand that the purpose of this config.py file is to load the configuration file, which is being done here, and it should load the env file, which is done here. So for this we are using pydantic settings underscore base settings, and we are saying that the environment file is going to have three things: rock API key, OpenAI API key, and app API key. So we are mentioning it, these things here. So if you are adding some other key value patch, right? Let's say tomorrow you are adding Google's API key, and you would have this another thing in your .env file. Now you should add this in this place. Like you would say that Google API key and it is a string, and you say that env file is .env. So now it automatically reads that and save this in a variable called as env config. So you see this class called as app config. So we are creating this object, and our environment values get saved here. Later we can access it using this app config env config. So the idea is, when you want to load this configuration file, configuration content, or the environment variable content, or the logger, you don't have to write all these codes again. Rather you can just like get all these things from your app.config and your app.logger, which are these files. So when I say app.logger, it represents this file, and when we say app.config, it represents this file. So this is how we can reuse these components. And then we have this. Let me look at the other things that we need in the services. You have QA service and so on. Okay, this is why it's creating, I think, a new content. If I open this main.py, app.logger. Okay, maybe later I can fix this. I probably shouldn't include this. That's why it's creating this thing. Okay, let's handle this later. Let's go through the other pieces of code. Then close this config.py, logger.py. So I hope everyone is kind of like okay with whatever we are discussed now. Now let's open this LLM folder that contains like the LLM related code. As you can see here, also I have this init.py, so that we can use this LLM as a module later. What this contains is like you are importing chat grok from LangChain grok. We are importing chat olama from LangChain olama and OpenAI. So if you want to use Google's, you can use that LangChain integration and so on. And then we are importing this logger. Okay, let me copy this in the services. That's why I think it's creating another logs. Got a error previously. Okay, I'll close this and say shouldn't. Yeah, this should be done. Okay, let me close this. I don't think this should create a folder after this. Okay, right. So here we have a file called as LLM factory. So the purpose is, when a user select a provider and a model, we are going to send this, and this is a pretty simple code. It may look complex, but it's actually pretty simple. We are importing chat grok, chat olama, and chat openai, right? And we are also logging this, and we have a function called as load LLM that's going to take two input parameters. One is provided details and the other one is model details. When the user sends the payload, something like this, let's say the user is sending the payload as Olama and model is Gemma 2 billion iteration, let's say Olama, right? So what it happens is we have a series of if and else if condition. So it goes into this try, and we have also added this exception, try exception block as well to have like a smooth operation. So if the provider is Grok, this line is going to run. If the provider that the user is sending in this input parameter is OpenAI, this line is going to run, right? If it's Olama, it's going to run. If they send a provider that's not accepted, we are going to say that unsupported LLM provider or something like that. Okay, let's say the user is sending Olama and Gemma 2 billion. Now this else if condition gets satisfied, so this LLM line is going to run. So we get chat Olama. So it's basically if it's Grok, return chat Grok with the specific model that the user is sent. So if the user has sent, let's say, Grok and Llama 3.370 billion versatile, then load the third Llama 3.370 billion versatile within this chat Grok and return the LLM. If they choose Olama and Gemma 2 billion iteration, then use chat Olama and load the specific model. It's basically what we have done. What I have did is just created like 3 if else block that would return the corresponding model. If the user wants Grok, we send the Grok LLM thing. If the user wants OpenAI, we send the chat OpenAI thing and everything, right? And finally, this is kind of like returns this LLM. All these are just like loggers and error exceptions, but this is like the key code. So we are choosing the LLM and loading the specific model and then returning that LLM. Okay, so this is what we are doing. Later, this returned LLM is kind of used to answer the user's question. Okay, so this is what we have this in the LLM content. So any other LLM related code, you can put this in the LLM folder. Okay, so let's close this, and then we have this API folder, and in this API folder we have two folders. One is DEPS, which basically is like the dependence folder, and the other one is like the routes folder. This deps folder, the depends folder, basically contains two files. Again, in it you can just ignore because we want this code kind of like a module, so we have included this. But the important file here is auth.py. This is kind of a standard code. I think this kind of took this from the internet, so it's not much complex. The main purpose of this code is verify the API key provided by the user. So that is all it kind of does. Okay, so we are like importing all this stuff, and what we are doing is, if you see this right, from app.config we are importing this env config. In this main.py file, this is imported, app.config is imported. When we import this config.py runs, and this two lines are kind of executed, which is like saving the values to the environment variables, right? So in this case, we are importing this env config from app.config, which is this variable, this object, which is this app.config, that loads this environment values as key value pairs into an object called as env config. So we are importing this. We know that it has three keys. One is Grok API key, OpenAI API key, and App API key. So when a user makes a request like this, right? So they send the API key in the header, and they send a body like this, right? Now we look at the headers data and look at this API key section and check for the API key values. That is what we are doing here. So here we have a function called as verify API key, asynchronous, which basically runs in the as an asynchronous process. All our routes run as asynchronous process. We can come to it later. So we say that it's going to need a variable called as API key, and this API key would be present in the request header. In this request headers, compare it to the app API key. env config.app API key basically represents the app API key value that you have in your .env file. So this is what we are extracting from this auth.py. Maybe I'll repeat this. In this auth.py, when we get a request, the user also sends a API key. We compare the API key received from the user, from the request, from the API key that we have in our environment file. So it's basically comparing these two and verifying that the user is an authenticated user. Now we can send an output. If this is kind of the two API keys are not matching, then it's like we don't authenticate it. If you remember, we have sent the output something like invalid API key, like in one of the requests, right? So this is happening like in this particular place. So this is what it would say, invalid API key, and this is the output that we got. So this is the entire idea. So this depends folder contains this auth.py file, and the purpose of this auth.py file is to authenticate a request. And then we have this routes that has three things. One is the self.py. This is the three routes that we are seeing, we have health.py, we have QA, and then we have select LLM, right? So these three routes corresponds to the three endpoints that we have. So we have this health, right? So slash health. This, when a request is made, this health.py file is called, and then this is where it says status okay. So everything is working fine. We should be able to access this route. It says status okay. And select LLM, which is this LLM option, is content is present in this select LLM. If you see this health, right, we have a router.get and slash path, right? So this slash health is what you are seeing in this slash health, and you're seeing this health, right, with uppercase H. So this is coming from the tag. Okay, so if you want to access the health route, first you have to mention the local host and the host and the port it's running, and put a forward slash and mention this, right? So this is how we say that health should be accessed from here. And if you go to the select LLM, which is the second endpoint, we would have given the path. Here we say that LLM, you have to say that localhost 8000 slash LLM options, and then send your request. And there is a tag called as LLM, and now you see the tag here. So similarly, we have QA, which is going to send the output once the user has provided the provider model details and the question. That's present in this qa.py file in the routes. So here we have LLM slash get answer tags. It's in the LLMs. It's like, so these two things are present in the same tag. And then we have an important aspect called as depends. In this dependencies, we say depends verify API key. Let's understand this. If you see this health.py file, we don't have that depends. But if you have the select LLM, which is LLM options API, and then you have get answer API, we have something called as dependencies. And in this dependencies, we have included depends verify API key. This is the part of authenticating the user. Okay, this verify API key is basically, if you just open this routes, sorry, the import statements, this verify API key is coming from app.ap.deps.auth, the same file that we have just now kind of discussed, right? So this is from where we are importing this, and we are verifying this API key. So similarly, your QA also would have this depends verify key. So that means your two routes. Health doesn't need this because we don't want to put this on the health, because it just does some basic health checkups. Apart from that, for select LLM and QA, we have this dependency setup. And then other stuffs are like pretty similar. We have response model. Response model basically tells like how the output should be, and then how the input should be. Like, we define all those things in this LLM options. We don't receive an input, right? So this is a get API, so the user doesn't send an input, rather we only like send an output. The output is going to contain like these things. It's basically a dictionary that contains like these kind of values. So that's what we are saying. So we are saying that the output would contain like three it's a kind of a dictionary, and it would contain like three of these parameters and so on. You can also make this generic kind of like a dictionary or something. Even you can kind of ignore this as well, but yeah, here we are saying that Grok, Olam and OpenAI, but a good option would be to make this generic, so we can work on that later as well. And we say that the output would be Grok would contain a list of strings, Olam would contains a list of string, OpenAI has a list of strings. So it's basically like the output structure of this, and we put it in the response model. Response model is like what your output structure is going to be. Okay, and then if you come to your QA, this is a post endpoint. That means it has an input structure and the output structure, because this receives the payload, right? So if you go to this post section, it receives a payload like provider, model, and question. So we have to be strict on this. So here we create a class called as answer request. Answer request in the sense like the request that we are receiving from the user should contain three properties. One is provider, the model details, and the questions. And all these should be strings. So we are mentioning all these things, and we are putting it in the request column answer request. So output model should be given in this response model in this router.post. So previously we have used in the select LLM and this health.py, we have used router.get. So that's how it determines whether it should be a get endpoint or it should be a post endpoint. So that's how it kind of determines it. So here we said router.get for health and select LLM, but for QA we said router.post. So that becomes a post endpoint, post method. We have tags. Response model is like how the output should be. Output should be a dictionary that contains answer as the key and string as the value. So that's what you're seeing here. So you have an answer as the key and the string as a value, large string. So that's how you can set up the output model. And this is the input model. Input model in sense like what are all the key value pairs and what's the data type. So we say the provider, model, question are the three keys required. And then we have strings and so on. And then we have this verify API key. And this input model should be sent to, here we are saying that the variable is request, and it should adhere to the model called as answer request that has like these three keys. And then we log this, and then we call a get answer method. Now let's look at where this get answer method is coming from. If I scroll this, I have a folder called as app.services.qa service, and from that I'm importing this get answer. That's basically present in this within this app. We have another folder called as services, right? And this is exactly where other stuff present. So for fetch LLM, for let's first discuss for this thing. So all your functional business logic should go into your services folder. So we have this LLM options which should return this. The code to return this is present in the services. So think about this correctly. Main.py file's purpose is to start the API, and the routes part is just to receive the input and send it, whether it's to select LLM. If it's select LLM, it sends to this services, app.services, LLM options, fetch LLM option. This doesn't handle the logic part. This doesn't kind of like handle the business logic part of the actual functionality, like sending the LLM. If you look at this qa.py, which is present in this routes, it doesn't do any processings and so on. It just like receives the request and then call this get answer. So all your functions logic should be present in your services folder. So this is again another standard approach that we have to follow. And if you see this LLM options, let me close all the files and open this main.py file and this LLM option. So LLM options loads this app config, where we know that LLM this app config is coming from this config.py file that's present over here, config.py file, and it has two purposes. One is to load the app config, which has like this configuration details and so on, and the other stuff is like just loading the environment file. So we don't need this, we just need this app config. So from this app config, this would have loaded this as a one dictionary, and from this dictionary I want only the LLM aspect. So I'm saying load the app config. So take that object, from that object, right, from this app config, take only the LLM and return that. So it's like filtering this LLM content and sending. This is exactly what we are doing. We are not doing anything complex. We are reading the app config file, the config.json file, and returning only the LLM content from it. So that logic is handled in services.LLM options. Okay. And if you come to this QA service, similarly, when you open this routes QA, this receive the request that we get from this LLM get answer, and then it sends it to get answer that we have from this app.services QA service, which is this file. And this is the core logic of our get answer thing. So it loads the LLM, and this load LLM is coming from the LLM factory. So let's say the user provides a model called as Grok, and then they say that it's a Llama 3.3, and the user sends a question. So now we call this load LLM, say that this is a provider that I need, this is the model that I need. So we use this load function, which I have already discussed. If it's Grok model, it's going to use this and return this LLM. So once the LLM is returned, we use this LLM.invoke and ask a question, and then we get a response, and then we return this. Okay, so this is the entire thing, and the only other thing that we have did is like add the logs in place. So this is like the entire framework, entire boilerplate. I know that it may sound a bit complex, but spend some time, go through all these things. Again, eventually you would get a better hang of this as we integrate more projects, more APIs to this. I'll just give you an overview of like what it basically contains. So again, this is a boilerplate code, and all the key files and folders are present in this app directory. And then we have a main.py file, which is like the entry script. And this entry script, if you see, we have this app config that we have loaded, and from there we are getting the host. What should be the host? In this case, the host is like localhost and 8000. If you see here, from this app config, we are getting the API. That means getting this API section, and from this API section for host, I'm getting the host details, which should return this localhost, and port details, it should return this 8000. What we are doing is, if we don't find any values there, use localhost as a default value. So it's not saying that host should run from localhost or 8000. Whenever you don't find something on the host or port, then run the API on localhost and 8000. This is just like a kind of a fail check. When the host and the port are not like given properly, fall back to this localhost and 8000. That's what we are kind of like mentioning here. And then the other thing that we have missed is like app include routers. So we have created a FastAPI API called as LLM API, right? Which is what you're seeing here. And we should tell the API that these are the routes that you have access to. One is health, /health, LLM options, and get answer. That's basically coming from this place. So we have this app.include router, include router, API routes.router. So this include router is kind of comes from this fast APIs thing. So this has this particular attribute include router, and this API routers.router is coming from this place. So if you open your app API, within this routes we have added something in this init.py. This is where we are saying that these are the three routes that you this API is access to. So this is something that we have to add in the init.py. So for these three routes that we have, we are adding this in the API router, and then later importing this in this space of include API router. It's like declaring these are the routers that I have in this init.py file in this routes, and later like adding this to this app include router. So this is how we know that the API, we say the API that these are the routes that you have access to. So that is about it. So we have this main.py file, which purpose is to start the API with getting like all those OS details, port details, make sure that you have loaded the app configuration and the environment configuration by running this, or basically by importing this, that will be taken care of, and everything. Set up your cores. Everything related to the API running is handled in this main.py file in our entry point script. And then we also have this in this app directory, we have API folder, LLM folder, services folder, and then we have config and logger. So these are like two critical things. One is like loading the configuration file, and the logger is just to log the details, and you don't have to write this code of logging and config again. So rather we can just like import this app.logger and app.config. We can use it wherever we want. In any Python script you can just like import it later. So that's why we have these two things. And API contains the dependencies with does the authentication, and route contains like all the different routes and the endpoints that we have. And finally we have the we have the LLM folder that kind of does choosing which LLM to use based on the user input and so on. Finally, we have the services, which is the critical aspect. This is the main thing that we probably would change, which is the core business logic and the actual functionality of the APIs that we are providing. Okay, so this is the entire structure. So once this main.py file runs, the API is running, and once a request is received, that's navigated to the routes, and from this API route, so from this routes the authentication happens, and if everything is working fine, from this routes everything goes to this service, and from this service like we either give the LLM options or we give the output. So similarly we can do this for like if it's a RAG application, we would have the services like for RAG QA or something, and have like corresponding routes in this routes directory, and everything kind of works from there. Okay, so I'll give the link of this repository in this video description. You can check this out. Please go through this. And I also have a README file. I have to change a few things. Go through this, but don't. Some of these things in the README file may change. But yeah, you can just like go through the repository. To run this, all you have to do are these things. First, run pip install. So install these libraries by running pip install -r requirements.txt. These things. Maybe I'll create a file called as start API steps. Okay, so these are the three things that you have to do. Once you have cloned this, say pip install -r requirements.txt. This is the first step that you have to do. After that, create .env file, put your API keys and everything with the same names that I have mentioned, right? So this is the exact folder structure that you have to follow, and then run main.py file. That is all. You should be able to run this thing. So make sure that, again, as I said, you don't have to understand each and every line of the code for now, but make sure that everything is running in your machine. Tell me in the comments if you are facing any issues, and we can like kind of figure out what's going wrong and we can fix that. But for now, clone this repository, have this running. Maybe you can watch this video a couple times and like fast forward it and watch this, but just try to get this code, like get a good understanding of this, and later maybe in the next video we would work on this similar boilerplate code for the front end, and then we can just like start with the projects which we are going to build on top of this. Okay, so I hope that this is like useful for you, and I'll see you in the next upload. Thanks for watching.